What if I told you that every plant on planet Earth was this close to being the color purple and not absorbing red and blue light for photosynthesis, but instead absorbed green light? This is the story of an unlikely molecular underdog that really would have never made it if not for one of nature's beautiful accidents.
Plants are green. You've known that since kindergarten. But here's something you probably haven't heard. Plants are green because they're rejecting the most abundant energy the sun gives us. The sun outputs more green light than any other color, and yet plants don't use it. They reflect it. So the question is, if evolution is so good at finding efficiency, why would plants ignore the best part of the spectrum?
This is a riddle so old, we need to go back in time long before the planet was the blue marble that it is today. Back billions of years ago, when the planet was a volcanic, tumultuous place to be, filled with green, murky oceans and purple life.
3.5 billion years ago, Earth was a very different place. The oceans weren't blue. They were murky and green. Not because of algae, but because they were filled with dissolved iron. And this iron didn't just color the oceans, it changed how sunlight traveled through them. Iron absorbs red and blue wavelengths, but it lets green light travel much deeper. So for hundreds of millions of years, Earth's oceans were flooded with green light. And the organisms that ruled this world, they weren't green, they were purple. These microbes use a pigment called retinol, which absorbs green light extremely well. Think of them as early solar panels perfectly tuned to the world they lived in. They sat near the surface, monopolizing the green spectrum. Anything below them was living in the scraps. And this is where one of evolution's greatest underdog stories begins. In the dim leftovers, under the purple world, a new kind of microbe evolved. Cyanobacteria.
This part really can never be understated. See, cyanobacteria had been using red and blue light for millennia before chlorophyll. What makes chlorophyll such a powerhouse is that it actually rips apart water molecules and steals an electron. This was really great news for cyanobacteria because now it could get all the energy it needed from the red and blue light waves from the sun and from the water around it. Cyanobacteria evolved a masterpiece, chlorophyll. And it might seem like life could have just sat back in a natural, perfect balance, but the Earth back then was anaerobic, completely devoid of any oxygen. And if it would have stayed that way, then yeah, it probably would be covered with purple bacteria, but none of us would be here. If it wasn't for the waste created by the ripping apart of these water molecules, a waste so toxic that it would completely reshape the entire planet.
It split water molecules and released oxygen. At first, oxygen was a toxic byproduct. Over millions of years, it reacted with the iron in the oceans. The seas literally rusted. All of that iron fell out of solution and it settled into what are now massive banded iron formations, some of the largest mineral deposits on Earth. So once the iron was gone, the oceans cleared. The green filter vanished, and suddenly, the purple microbes, the ones optimized for green light, were in trouble. Meanwhile, chlorophyll, a pigment built to survive on leftovers, was suddenly bathing in full spectrum sunlight, and that changed everything. Cyanobacteria thrived. Oxygen filled the atmosphere. Life shifted from purple to the green world that we know. However, when plants left the ocean and colonized land, they faced a completely new challenge: heat. Infrared light carries a lot of energy, and if you absorb too much, the plant overheats, damaging its cells. So plants evolved a clear solution. They reflect both green and near-infrared. This was an early defense against the sun's natural infrared that heats them up. Reflecting green light was never a deliberate choice. It was an inherent side effect from their cyanobacteria ancestors. Plants never needed green because their ancestors evolved in a world where green light was already taken. But reflecting infrared, that was a whole new strategy for survival. This dramatic jump in reflectivity between red and infrared creates a signature scientists call the red edge. Plants' reflection of red is so strong that we can detect it from space with infrared cameras. This is actually how satellites monitor forests, crops, droughts, basically the pulse of Earth's biosphere.
So this first one on the left here is a true color image. This is what it would look like if you're flying over in an airplane and looked out the window. It also can capture in these much longer wavelengths, and that's where we get these kind of funny colored images over here. And this is really helpful because there's a big difference in how things reflect in the longer wavelengths, as you can also see here. And having these longer wavelengths enables us to better distinguish between different land covers and better be able to detect when there is a forest disturbance.
And when we scan distant planets, we look for the exact same spectral fingerprint. Finding a red edge on another world would be the closest thing to detecting alien vegetation. So why are plants green? Not because it's optimal, and not because evolution really wanted it that way. Plants are green because billions of years ago, Earth's ocean filtered sunlight into a world where green belonged to something else. Chlorophyll evolved as a workaround, a second choice pigment that happened to produce oxygen. And that accident transformed the atmosphere, creating the world we know and made complex life possible. Plants are green not because they're efficient, but because they're ancient. And when we search the galaxy for life, we're not looking for blue planets. We're looking for the red edge, a clue that somewhere else, evolution made the same mistake.